Hello grade 11s. Today we're going to consolidate a bit of work on geometric sequences and do a little bit of investigating to prepare for our next lesson, which is on geometric series. Hopefully you've had a quick go at this question already. It's just really getting the idea that percentage change is also a type of, it is a geometric sequence, and it just takes a tiny bit of thought to convert it into a common ratio. So we have this problem looking at daily users of Snapchat. The increase of 2.5% per month is linking to our common ratio. So if we wanted to find out how much it would increase in 1 month, the easiest thing would be to multiply by 1.025. So that would increase our amount by 2.5%. So that is R. R is 1.025. And here we have U1, the first term. So I'm considering U1 to be the first month, which is May 2018. Part A then, determine the number of daily users in December 2018. So if we're thinking about December, May is U1, December is going to be U8. So we can just use our formula. We'll take U1, 187 million, multiplied by R to the power of n minus 1, so to the power of 7. And this comes out at roughly 222.28. So we could say that there are roughly 222 million users. Part B, find the month of which year when the number of daily users first exceeds 300 million. So we've got a few options here. We could solve this as a kind of inequality, or we could use the table function, which is probably our easiest option. And I'm going to do that by entering our nth term as my function. So U1 times R to the power of n minus 1. And I'm going to look at my table function, and we're looking at 300 million. So it's happening around here. And to kind of communicate what I've done, I'm going to do a little table with n, un. So when n is 20, and when n is 21, 298.9 is 20, and 306.4. Okay, so clearly, when n is 21 is the month where the daily users exceed 300 million. So we just need to figure out when is n equals 21, and that is January of 2020. Right, I'm running out of space a little bit here. We're going to take a little look at part C, and we're going to look at how to work this efficiently with our calculator. So the company aims to reach 300 million daily users during May of 2019, so clearly a bit earlier. Determine the monthly percentage increase required to achieve this goal. So clearly that common ratio is going to have to increase if we're going to get to 300 million before January 2020. So what we're looking at is changing our nth term and saying instead of 1.025 we want to find this value of r, and that would be n minus 1. So we're changing it now. Which month is this? If it's May 2019, that's going to be, well, May 2018 was month 1, so May 2019 will be month 13. So we would like 187 times r to the 13 minus 1 to be equal to 300 million. Many options on how to solve this. We could do it algebraically, we could graph both of these and look for an intersection, or we could use the Solve app on our calculator. So let's just review how to do that. We type in our equation, 187 times our unknown, which is coming up as a to the power of 12, equals, there's this here which you can use as an equals, or it's shift and then the decimal point, equals 300. Okay, so to get a solution to this, I'm going to go to the table and I'm going to put in a guess. Now, I know my guess has got to be, it's going to be 1 point something, isn't it? Ideally a little bit bigger than 1 point something. So I put in a guess and I'm going to press solve. Okay, and we get 1.04. So a little bit bigger than the previous one. So R equals 1.040 ... And just to answer the question, determine the monthly percentage increase. Well, this isn't the percentage increase. The percentage increase is the 4% that we're adding on here. So the 1 represents the whole of that month, and then the 0.04 represents the increase. So the percentage increase must be 4. Let's get another figure. 4.02%. So running to 3 significant figures. Folks, please, by all means, have a go at a few of the classwork questions, but I'd really like you to get on to looking at investigation 3 during our class today. So investigation 3 will probably take you maybe 15-20 minutes, so spend 10 minutes working through it and then come back to this video and spend 10 minutes checking through anything you want to review. Hopefully by now you've had a chance to look at this. This is really leading you into your lesson tomorrow. So we're going to take a look at some of this in advance. We've looked at this idea of SN when we were talking about an arithmetic series. So that is where we're adding up the terms in an arithmetic sequence. And it's the same notation when we're talking about a geometric sequence. So if we want to add up the terms of a geometric sequence, we're finding a geometric series. So we're looking at the first 5 terms of a geometric series. You can see it's all quite general now. We're going to try and come up with a formula that will help us find the sum of this series. So question 1 says write down an expression for RS5. We've got S5, all we're doing is multiplying by R. So I'm going to have to write quite small here. So RS5 is simply multiplying each of these terms by R. Okay, pretty straightforward. Hence is an important word in maths exams in particular. It means to use what you've just done. Hence, find an expression in terms of U1 and R for RS5 minus S5. So we want to find RS5 minus S5. Now, this is going to simplify quite nicely. I think what I'm going to do is write out RS5 and I might write S5 underneath it. So this is RS5 and I want to subtract S5, which we have here. And hopefully you've already noticed that a lot of this will cancel. So I'm going to take this and I'm going to subtract this. And what we'll see is that This term will cancel with that. This will cancel with that, and so on. And all we're left with is u1 of r to the power of 5 minus u1, which of course we could take a factor of u1 out, r to the power of 5 minus 1. Okay, we also need to find, let me just write this here. We also need to find an expression for S5. Now we've got all of this, and factorising the right-hand side makes me realise we could factor the left-hand side as well. So let's take a factor of S5 out. And this really helps us with answering the next part, part B. I want to find S5, so I could just divide by r minus 1. Okay, and now I've got an expression, or I've got a formula for finding the sum of the first 5 terms of this geometric series. And obviously, having a different power, having a different number of terms, the process will be the same. We'll multiply all of them by r, they'll cancel, leaving the largest power from the r times your series and this one without a power. So you'll always be left with those 2 terms. And we can see that this would lead us to this result, a more generalized version. So this is a formula from your formula guide, and it is the sum for a geometric series. Notice one thing to be careful of is with our nth term in our formula, the power on the r is 1 less than your value for n. In the series, the sum of the series, they are the same. Okay, and that's because we've taken this term at the end where the power was matching. Obviously, if your series is a series that's decreasing, so maybe it's starting at 10 and r is a half. So every time you're going along your series, the values are getting smaller. If that were the case, and we weren't using a calculator to do all of this for us, we'd probably be wanting to subtract these the other way round, because the further along we get, the smaller the values we are. So to avoid having negatives, we probably want to switch the way we did this subtraction. And that leads us to this other version of the formula, which is also in your formula guide. So this version is useful if your sequence is decreasing. However, saying that, we do so much with our calculator now that we aren't really having to deal with those negative values. Okay, let's just take a quick look at this in use. We're not going to do a lot on this now. In our class on tomorrow, you're going to be looking at using this a lot more. So this is one of those famous stories of in maths. I'm sure it's one that you have come across. And it's this idea of a sequence where sometimes it's grains of rice, but sometimes it's grains of wheat. And the inventor of the game chess has said that for their reward they would like 1 grain of wheat on the first square, 2 grains of wheat on the next, 4 on the following, 8 on the one after that, and so on. So it's a sequence that is doubling. Okay. So we have to find out how many grains of wheat would need to be provided. And we can do that using our formula that we've just found up here. First of all, it's useful to know that a chessboard is 8 by 8 wide. So we are looking up to when n is 64. We know the first term is 1, and we know that the common ratio, the amount we're multiplying each time by, is 2. So to find the number of grains of wheat, we're going to find S64. So let's check our formula. We can use this one up here, or we could use either really. So U1 is 1 times R to the power of N minus 1 divided by R minus 1. Okay, obviously use your calculator for this. You will end up with roughly 1.84 times 10 to the power of 19 grains. And depending on which version of the story you read, this bankrupts the king because he cannot provide this. And looking at question 5 follows this up. So question 5 says, how does this compare with the annual world production of wheat, consisting of approximately 1.2 times 10 to the power of 16 grains? Now, an obvious answer would be, oh, it's much bigger. A slightly more rigorous answer would be to think about how much bigger it is. So if we take this value we've just found and we divide it by the annual world production, we can see from this part of the calculation that it's going to be over 1,000 times bigger. And this comes out at roughly 1,537. So what does that represent? It means that it would take, if this were the world production of wheat and it stayed constant, it would take approximately 1,537 years to fulfill this this amount of wheat. Okay, you will spend some time looking at geometric series tomorrow, but it's nice that we've had a chance this class to look through some of the basics of it. Please make sure you try and finish off the homework exercise 7b, looking at percentage change and linking it with geometric sequences.